is often indicated by this symbol. And so in this set of numbers here, the sum of the x's is 23. So the mean is the sum of the x's divided by n, which would be 23 divided by 6. One other thing that I want to go over, and you may not have seen this for a while, is the order of operations. And when we do the order of operations, that says that we do what's inside of parentheses first, then we do exponents, then we do multiplication and division, and then we do addition and subtraction. And on these guys here, we do those from left to right. And you may see that in something like, 4 plus 3 divided by 2. So you do what's inside parentheses first, which should give us 7, and then division divided by 2. So the answer here is going to be 3.5. If you haven't seen that, you may want to brush up on the order of operations a little bit. Okay, another thing that we'll see is the factorials, and we indicate that with the exclamation mark. So 1 factorial is going to be equal to 1. 2 factorial is 2 times 1, which is 2. 3 factorial, 3 times 2 times 1. It's just, you just multiply it by all the numbers that are below it. That gives you 6. 4 factorial, let me introduce this. We can go through and we can say 4 times 3 factorial. So that's going to be 24. 4 times the 6 is 24. By definition, we know that 0 factorial is equal to 1. I can give you a proof for that, but you probably be best just for you to assume, or just to accept that by definition. Factorial is not defined for negative numbers or for anything besides the counting numbers or the integers. If we had something like 15 factorial over 13 factorial times 2 factorial, and you'll see this later on in the course, you don't want to go through and say 15 times 14 times 13 times 12 times, because it just gets to be too much of a problem. So if we recognize that this is 15 times 14 times 13 factorial over 13 factorial times 2 times 1, then we can cancel these terms, and then we can cancel the 2 with the 7, 2 times 7, which is 14, and give us 7. So this is actually just 15 times 7, which makes the calculations much easier. Some other symbols that we'll encounter are things like sigma, which is going to be representative of the population, standard deviation, and then the letter S, which is going to be representative of the sample standard deviation. So when we use the Greek symbols, it represents the population. When we use Roman symbols, it represents the sample standard deviation. The problem is that when I send you out an email, it's going to be hard to go through and get this symbol. So a lot of times I'll just say something like SD. Later on we'll find out that another symbol that I use a lot of times if I'm sending you an email trying to explain something to you is this SQRT. So the square root of x squared, that's going to be equal to x. Mathematically, you may see that something like x squared. So this symbol here, I'll just say SQRT, and that does make it a lot easier when I go through and start trying to write that out and give it to you in an email, especially if you don't have HTML enabled on your computer. Some other things that you'll see throughout the course periodically will be things like x1, x2, x to the n, where you have these subscripts. That just indicates that this is the first x value, the second x value, all the way up to the nth x value. And they will obviously be, the sum of all of those would be the sum of the values as you would need. Well, hopefully this has been helpful to you. And again, let me emphasize it throughout the course that if you have questions about this, don't hesitate to ask. I really do want you to understand these things, and if you're having a problem with it, a lot of times I've found that I can go through and explain it to you and solve you save a lot of problems.